In a machine learning ecosystem, you will typically need libraries, development environment, and services to provide support for the entire development process. In a typical machine learning ecosystem, you will use libraries such as scikit-learn, which is a classical machine learning library, and Keras, TensorFlow, and PyTorch, which are deep learning libraries. One of the most popular development environments is Jupyter Notebooks, where you can use Python to write your machine learning code. Other examples of development environments include Azure Notebooks, Azure Databricks, Visual Studio Code, and Visual Studio. You need a service to provide support for the development process, and this is exactly where Microsoft Azure Machine Learning comes in. It is a leading cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers. Executable or interactive notebooks have a long history in science and academia. Notebooks were traditionally provided by applications such as MATLAB and Wolfram Mathematica to help scientists, students, professors, and mathematicians create self-documenting notebooks that others can use to reproduce experiments. To accomplish this, notebooks contain a combination of runnable code, output formatted text, and visualization. Over the past several years, web-based interactive notebooks have gained popularity with data scientists and data engineers to conduct exploratory data analysis and model training using several languages such as Python, Scala, SQL, R, and others. The most popular notebooks in use today are Jupyter, Databricks Notebook, R Markdown, and Apache Zeppelin. Notebooks are made up of one or more cells that allow for the execution of the code snippets or commands within those cells. They store commands and the result of running those commands. When the notebook is saved and shared with others, any outputs can be included so others can see that intended outcome of each cell. In this diagram, you can see that we use a notebook to perform the 5 primary stages of model development: collect data, prepare the data, training the machine learning model, evaluate the model and choose the best one, and deploy the model. There are many services and tools within Azure that support the end-to-end data science process. This diagram categorizes the options by model training on top and model operationalization on the bottom. For model training, you can conduct your training locally during early stages of development or against smaller datasets using a local machine or VM with the Azure ML tools, local Jupyter Notebooks, Visual Studio Code, or Docker container. You can train and test models remotely by using an Azure Data Science virtual machine, which contains tools preloaded for you. You can also scale out your training and testing by using Azure Databricks, Azure Machine Learning Compute Instance, or SQL Server Machine Learning Services. For model operationalization, you can test and debug containerized models locally with Docker. When you're ready to deploy the containerized model in the cloud, you can use Azure Kubernetes Service, also known as AKS, or Azure Container Instance, also referred to as ACI, as deployment targets. Use your serialized models for remote scoring within Azure Databricks, Core ML, or SQL Server machine learning services.